This is a Jupyter Notebook demonstration of running analytics on coverage data sets with the Science Data Analytics Platform, or SDAP. Nexus is the SDAP analytics engine, and we have two ways to interface with this analytics engine. One is with a Python API called the Nexus CLI, the Nexus command line interface. And the second is with simple web service calls that can be done in a variety of languages. So we're going to start by setting up the Nexus CLI and the base URL for our current SDAP deployment, which is on Amazon's AWS cloud platform. So I'll do that now. So now our URLs for our RESTful service calls to SDAP will start with this prefix, which is to a load balancer in front of our SDAP deployment. This is a lightweight SDAP deployment with one master node and 3 worker nodes. Next, I'll set up the bounding box and time range and data set for the demonstration. And here I've selected a 30 by 15 degree bounding box in the Gulf of Alaska. And I'm using a data set from JPL called MUR, and this one is a 25 kilometer resolution sea surface temperature data set. And I've chosen a 1-year time period in 2017. So I'll do that now. And as you can see in this diagram, the green bounding box here shows the spatial region we'll be investigating. So one of the basic capabilities that we have built into SDAP is to query for the data inventory. So these are the data sets that have been ingested into SDAP and can be used for analytics. And here I'll use I could use either the Nexus command line interface for this, or a simple web service call. And in this example, I'm using the basic web service call using the Python request module. And I'll run that now. So this is the list of data sets that come back. Our sea surface temperature data set is here. Right here, it's the MUR 25 kilometer data set, and you can see the time range that's available in this has been ingested. And the tile count, that tells the number of data tiles that have been ingested into SDAP. The way SDAP works is that the data set is broken apart into spatial tiles, and then those tiles are read into SDAP. They're stored in a database that allows rapid geospatial lookups, and we can very quickly subset the data set and query for which tiles fall within a user specified bounding box. One of the analytics we have built into SDAP is the area average time series. In this one, we get a single value back for each timestamp, and that value is the spatial average within a bounding box specified by the user. So here I'll run this analytic algorithm, and as I mentioned, we have two ways this can be called. One is to simply make a web service request to a URL that looks like this, where we have our endpoint specifying the algorithm to be used. and then the parameters are specified as part of the URL. And alternatively, we can use the Nexus CLI to make this call. This is the Python interface, and the same information is specified using Python objects. So here the time series ran, took a few seconds, and next I'll plot the result. So here I'm just using some Python matplotlib library to do the plot. And you can clearly see the over this 1 year time period, the seasonal cycle is clearly evident. We also have an option to remove that cycle if desired. Another analytic built into SDAP is the time average map. In this one, each grid cell is averaged over time, and the result is a two-dimensional map of those time averages at each point location. So I'll run that now. And this is the URL is generated. It's in this case it's identical to the time series URL, except the endpoint here is different, but the parameters are all the same. And you can see that this ran in about 9 seconds. I should mention that all of the analytic algorithms in SDAP produce an output in JSON format so that it can be very easily interpreted by web browsers and by other programs that may do post-processing on the result. So here I'll just quickly show this is roughly what the JSON result looks like for time average map. We have our coordinate here and the mean value at each location. And the count tells how many data points went into that calculation at each grid cell, because there could be fill values and masks that are interpreted and omitted from the calculation. So we have our time average map result. I'll extract the actual data from that JSON response and use the Python matplotlib library to produce a plot of the result, and we can see it. This is how it looks. We have the map and a color bar, and that concludes our demonstration.